Hello everyone, welcome back to Advent of Code 2020. It's day 4. Still can't really make out what we're building here. Is it a toboggan maybe? We've done a lot of tobogganing. Day 4. Let's see what the puzzle is all about. Day 4, passport processing. You arrive at the airport only to realize that you grabbed your North Pole credentials instead of your passport. While these documents are extremely similar, North Pole credentials aren't issued by a country and therefore aren't actually valid documentation for travel in most of the world. It seems like you're not the only one having problems, though. A very long line has formed for the automatic passport scanners, and the delay could upset your travel itinerary. Due to some questionable network security, you realize you might be able to solve both of these problems at the same time. The automatic passport scanners, I feel like, I don't know. In every year, there's like, in each puzzle, some like thing you can highlight, and it has like alt text of some kind, and they reveal it to you if you've given all 50 answers. I just thought questionable network security might be a cute thing to alt text, so I checked, but no, apparently not. The automatic passport scanners are slow because they're having trouble detecting which passports have all required fields. The expected fields are as follows. Okay? Passport data is validated in batch files, your puzzle input. Each passport is represented as a sequence of key value pairs separated by spaces or new lines. Passports are separated by blank lines. Okay, so each line, this is by spaces or new lines. All right, that's fine. So this is a blank line separates passports, but a new line doesn't. Okay, fine. It's valid, has all 8 fields. 1, 2, 3, 4, 5, 6, 7. Did I miss one? Oh, I scrolled down too far. This is the first passport. And it has 4 on each line. Okay. The third is interesting. The only missing field is CID. So it looks like data from North Pole credentials, not a password at all. Surely nobody would mind if you made the system temporarily ignore missing CID fields. Treat this passport as valid. Okay. That seems fine. Treat CID as optional. Okay, so let's So we'll make a day 4 project. And we'll get our input for day 4. And move over to the day 04 sources, and let's go back and look at our input. By the way, I only noticed now that I was invoking my previous solutions by piping them input.txt on standard in. But actually, these programs ignore standard in. I forgot that I updated the template last year to just read input.txt implicitly, so I wouldn't have to do that redirecting. Anyway, so what's my input look like? Anything weird here? Not really. It might be nice to like actually parse these things as meaningful values, but for now we're going to just parse them as strings. Key value pairs. And I don't think I will like define I don't think I will give any definition of the meanings of these strings. I'll just collect them all and define a set of like required and see if they are the same as the set that are present. So let's get started on that then. What do we need? We need to import data set as S. It's warning me because I'm not using that yet, of course. And we need import text regex applicative to do the parsing. Which, yeah, we could totally do this with a regex. We don't need a parser. Actually, I don't want a set, do I? I want a map. Because I want to store the values as well as the keys. And then we'll just look at the list of keys and see if it's equal to what we were expecting. Count the number of valid passports. All right. So what is our input going to be? It's just a string, I guess. No? No. Let's just define a type for, let's not. Let's have our type be, yeah, let's, I don't know. Type, passport is an mmap from string to string. And our input is going to be a list of passports, which we will parse in both of our, we will parse the same and prepare. And then if necessary, in part 2, I assume we'll have to do something with the values. So now we need a regex. I need to go look at the docs for text regex applicative actually text. Is there a way to get like the remainder when you're done parsing? Or do I have to split on new lines first? Here. Finds the first prefix? Prefix of what? What are these? Find first prefix, I think is what I'm looking for? Yes. It's actually a little bit complicated, I think, to parse. Because when you consume the new line, I don't know. It's only the last entry that's tricky because it's the only one that doesn't end with a double new line, I think. So I probably should split the string by double new lines first, and then parse each one of them, just treating all white space as interchangeable, right? Yeah. That's better than trying to have one regex that does everything. Okay. So then I don't need any of this nonsense. Although, how do you... Haskell split list, I guess? Haskell split string? I don't know. How to split a string. What's the way to do it? Data list split, of course, has it. That makes sense. I mean, actually, maybe we could just use regex applicative to split the string on new lines? Let's get back to looking at this briefly. Find first, find longest, find shortest. We don't need a custom uncons. I mean, this is kind of like, I don't know, I guess you write a recursive function with find first prefix, which is pretty stupid, I think. That's the opposite of what I want anyway. It doesn't do splitting, it does matching. Okay. Well, we'll just do it by hand, I suppose. New line, or let's say records separated by takes a eq a and it takes a list of a to split on and a list of a to read and returns a list of a. Oops, don't double up the a. Actually, I didn't need to copy that, right? I could say records and then, yeah, Emacs will autocomplete it for me. Of delimiter and nothing is nothing, I guess. I shouldn't ever actually run into this edge case, I think, though. Boy, I should just import data list split. This is like a ton of work for no reason. Okay, so if I build this, is it going to find split? Yes. Everything looks fine. I never know how Stack and Cabal interact. It's a complete mystery if anything is going to work. Completed, couldn't match. Oh, my file is wrong. That's fine. But it compiled all my dependencies. So actually, let's put these back. I don't know. So how does split work? Yeah, so let's map parse. Oh, let's call it passport. Composed with split on double new line. Import data list split on. Okay, now where, oh, not map, but traverse in the same way we did before, right? And we'll just say if anything doesn't parse, we'll throw the whole thing away. Import data, maybe from maybe. Where passport equals I don't know, this, and R equals oh, I'm gonna have to do more, right? Convert to a We're gonna parse out a list of pairs, I guess. So m.fromList. I guess we want actually to fmap m.fromList composed with this. Or no, passport. Am I crazy here? Like, this match is returning a single, maybe list of pairs. Yeah, I guess this is fine. Okay, now we just need to write the regex. So it's gonna have to be a tuple somewhere, mapped over parsing. No, that's not right. The end result is going to be a list. So it'll be many of field. And I guess field will be a tuple, and we're going to skip any number of, I don't know, lm of space or new line, but ignore it. So the idea is at the beginning of each field, we want to remove new line, not at the end, because then we would consume the new lines. Oh, we could do it at the end, actually. It doesn't matter, because right, we already split up the records. So either way, it's fine. So any number of white space, and then a many. Oh, I have to say psim of this. Psim of not colon. No matching parenthesis found? What do I have wrong? Hello? What? Sure looks right to me. Did I not close this one? That looks closed. What the hell? That one closes. That one closes. That one closes. That one closes. Why was it not closing a minute ago? That one doesn't. Let's just close them both and hope it works. And we're going to then ignore sim colon. Many, yes. Let's get these things on different lines, I guess. It's like acting like this is part of my string. I don't understand why that should be. It's like this file is parsed wrong. I don't understand. Unbalanced parentheses? What? This is baffling. And this is indented like it's still inside this string. Like these are just normal quotes, right? Do I have a dangling quote somewhere else? No. Dangling double quote? No. They're all in the right pairs. What? My parentheses all match with something obvious, right? I don't know what the hell is going on here. I might like restart Emacs. This is bizarre. And anyway, then we want many, no, we want any, okay, let's define white space, I guess. We want to match any non-white space here, right? Is that in? I was going to look up if there's like a predicate in Haskell for is a thing white space, but that's just it's just so easy to write. It's just this. I'll just put it here. White space equals this. White space is actually longer, almost as long as typing this out, but the point is it's clearer now, right? Many psim of not white space. I think that's about right, yeah? And as far as Haskell is concerned, this file parses just fine. I don't know why Emacs can't handle it. Hello? I can't type again. This happened yesterday. It was like it was tab completing something. Maybe I accidentally hit tab. This looks fine now, although it is still, it's colored wrong, but at least it understands where the braces are. I don't know what the hell is up here. So what's wrong with this? All right, let's give R a type. R is an RE of char to mmap. Oh, I already have that, don't I? Yeah, passport. So this is wrong even if we have that, huh? Oh, it's not passport, it's a pair. It gives you pairs of strings and strings. Oh, it gives you a list of pairs of string and string. Okay, so this is correct, but R actually is not implemented correctly. Okay, and field is an RE char of string string. RE. All right, let's get some more. Okay, we have this now. So we're saying many psim white space, which are being thrown away, then parse this, then throw away a colon, then parse many non-white space. This seems right. But what do I actually have? An RE of char and single string. Oh, I need somewhere in here to have a double-sided pointy thing. Here, I guess? Now what? Well, that sucks. I guess maybe I wanted this? And that looks still wrong. Just guess. Oh, okay, this is kind of weird. What is it saying? In the first argument, I never know how these things group. Ugh. Okay, I'm not as good at applicatives as I should be. Okay, maybe just throw in some parentheses. Oh, whoops. It would go here. It's still just as wrong as it was before. So what I have... I don't really understand this. It's hard to tell which of these they're pointing at, right? In the first argument of this. So yeah, it's expecting a function from string to pair of string and string, which is indeed what I expect to be on the left of this thing. But actually, no, actually that's not right. It should be. I expect it to be a list of char, a parser for string. Okay, so I want this. Let's just give it all a type. I expect that to have this type, and I expect this to have this type. What are you lighting up many for? Yes, I know it's redundant, thank you. Well, is it though? Oh my god, it's not handling the parentheses again. Excuse me? Why is it correct now? Adding those types shouldn't have fixed anything, and I don't think I added any parentheses that were important. Maybe it was this one, but I thought I'd already added that. If I remove this, does it still parse? No. It's apparently it is not. Oh, this one is redundant, maybe. That makes sense. And I don't need these types, right? I mean, I guess they're fine as annotations to point out where the stuff we care about is. Huh. All right. I don't love this, but if we said like prepare of, let's say this, and I have to put in the new lines. Actually, I probably have to. Yeah, I probably have to do that, right? Something like this. Excuse me? What are you're not even like willing to do anything? Why not? It just like says nothing. I'm very puzzled by what happened there. It evaluates one. Prepare for this. Says, oh, there's nothing there. Oh, did I leave too many new lines at the end and it got mad? So this failed to parse. Fine. So let's remove everything. That one parses. Okay. Now if I put a new line at the end, that's the problem. I should actually be removing new lines or space at the end of each passport as well, because there's a new line at the end of the last one. Okay, now it parses even with a trailing new line, and a pair of them parses just fine. Okay. So now we can write part one pretty simply, I think. Kind of a gross parser here, but all right. Part one is, again, length filter valid. We want an int. Where valid p equals let's look up how data map works. Haskell data map. How do you remove something from a map is what I want to do. Data map strict, of course, you're right. Deletion, update. We just have delete, and if it's not there, it's fine. Okay. Valid p equals I think we can assume that all the inputs have no completely made up entry keys. So we'll say equals 7 dot oh, hang on, here you are. Equals 7 composed with length composed with m dot keys. Yeah, keys. M dot delete, and I already forgot the order that this goes in. Takes the key first, which makes sense. CID. Valid. What? I have a function from passport. Oh, I shouldn't need the P there. There we go. Actually, what if I just stack exec? Does that work? Stack run? Yes, that's why I did it this way, is that now it's easy to... All right, 237, that's a number. I like numbers. I put it part 2. All right, well, we'll enter this and see if the site likes it, and then we'll move it to the right place. That's the right answer. Okay. So before we look at part 2, let's just go fix this, which is easy. We just put it back up here and change the names. Okay, I'm actually going to take a quick break before we get to the remainder of the puzzle. All right, I'm back, and we're actually not yet going to look at the next part of the puzzle. I want to take this time to proselytize again about the value of composable regexes. Notice that we wrote a single regex that matched all of the fields in our thing. Even though there are arbitrarily many, this would parse 100 fields. We didn't first scan the, we didn't match a single regex against the input many times and extract groups from each one. And we didn't have a capturing group for each field. We just had a single regex that matched all the fields at once and split them apart properly. This is because with a regex where individual parts have meaningful values, it's easy to take a regex for things and a regex for list of things and combine them into a regex for lists of things, right? In the same way that you can take an A and a list of A and make a list of A, you can do the same thing with regexes. And so it's easy to make a parser that handles lists of A's and understands all of them as individual entities, rather than just having to if you have a something in a regular regex, you might write in a PCRE style regex, you might have written you might like to write /w plus colon / I don't know, S, we want groups there, S plus, maybe /S star in there somewhere. You might like to write this regex saying match a string that's the name, ignore a colon, match any amount of non-white space stuff, and then throw away some white space, and match that any number of times. But you can't, because this group itself is being repeated, and you only get the results of one of those repetitions. Likewise, these groups, these inner groups, they're being matched multiple times, and you only get one of them. But because we don't have to express our regex down to a list of strings at the end, we can make sense out of the individual structure in the middle of it as we parse. So just more about how applicatives are pretty cool and strings kind of suck in general. Anyway, back to part 2. I should commit it. I'll try to remember to commit before we get started. The line is moving more quickly now, but you overhear airport security talking about how passports with invalid data are getting through. Better add some data validation, quick. You can continue to ignore the CID field, but each other field has strict rules about what values are valid for automatic validation. Birth year is 4 digits, and okay. You have to be at least 18 to fly, I guess, okay. Issue year, yeah, has to be within the last 10 years. Boy, short people aren't allowed to fly? Oh my god. 59? I mean, you have to be at least 5 feet to fly? I mean, I don't know how much 1.5 meters is, but... Okay, geez. Okay, that seems fine. We can just define a little language of predicates for these things. No problem. But first, A4 part 1. Cool. Now, we want probably to delete CID first, since we're just ignoring it in all cases. Oops, what did I do? And do that in prepare. Okay, that should still be valid, right? We're looking for 237 as the answer. Yeah, cool. Day 4, move, deletion. I don't know, I can just do this. I can just have this be part of day 2. Part 2, I mean. So what we need now is we kind of want to type rule, which is, let's say data rule. Why not? Data rule is a rule of the expected, or the key, rule string and string pool. I guess we could rule of A, right? Be generic where possible. And actually, we don't even really want this type. We want a map from string to the rule for that type. So yeah, I guess what we want is rules, which is a m map from string to string to bool. Is a map the best way to do it? We could also just, since we know all of our passports will have exactly 7 fields, we could like zip them together with a list of 7 rules and apply the rule to each. That doesn't seem like a very good model of the domain, though, does it? I don't think so. And for now, our list of rules is empty, and we'll add some rules in a minute. But first, we need a little sublanguage for building rules. Year rule is a function from let's call it a range rule. Is a function from int boy. Should we actually parse these things? I hate that idea. A 9-digit number including leading zeros. There's got to be like, is there replicate A in Haskell, like replicate M? Yeah, there is. Okay, cool. Although this is not in, it's in containers. All right, I'll take it. No, but that's for sequences. Do you need sequence? Like, you can build it out of sequence. It just seems kind of dumb. I'm just thinking, like, how do you say I want to match something n times? Oh, interesting. It has a non-greedy match. Okay. Maybe I could have matched a few new lines and not split. No, probably not. So what I kind of want is like something that takes an applicative and an int. Let's ask Google, shall we? As I've said before, a person's search engine is a very intimate thing that I would not share with any strangers. So even when I'm just browsing to a new page, I have to send you guys away for a moment. You never know. So what I wanted to look for was like an int and I guess I want like applicative f, int fa, like that. There's replicate m. Oh, it's still got the m in its name, but it works on any applicative. Okay, fine. Cool. So I was just thinking that would be useful for this, like exactly 9 numbers, or this exactly 6 characters. These we definitely do want to match with a regex, like all of these. But these we want to... We kind of have to parse them because we can't even count on them being valid digits, right? So I need to write a parser for them and then use maybe to, if it matched, asserts that it's valid and otherwise give up. Okay. So I guess I kind of want, in fact, a regex rule that I'm going to apply to all of these. So let's say rule is a function that takes an RE of char to A, and then a function from A to bool, and returns a bool, whether it matched. Rule RE, oh, and it returns a string to bool. Now this parenthesis is redundant, but I kind of want it to be clear that a string to bool is kind of what we're thinking about. You know what, actually, let's just type rule equals string to bool, and then I can say rule here and here. I didn't think I would end up needing it more than one time, but okay, fine. Rule of RE and predicate equals maybe pred composed with matching RE. What's wrong with this? Maybe is not imported, is that right? No, it is. Oh, I need a default, right? Maybe false pred? Looks good. What are you upset about here? Oh, pred is shadowing. We'll just call it valid then. Okay, so now we can write our rules by just specifying a regex and then what to do with the result. So now we can write a range rule. No. Let's write between. Kind of stupid, but int, and then it returns I guess an int to bool. Bool A. No, because we're going to have a map. We want a string rule eventually. Yeah. Okay, so we just have a function from now int to bool. Between low, high, x equals x greater than or equal to low and x less than or equal to high. So we can then write like int is an re of char to int equals read over many is digit, which we need from data char is digit. Oh yeah, something's wrong here. No wait, is it? I need psim, right? Okay. So now we can say we want a rule of int between 1920 and 2002. What's wrong with this? Oh, yes, we now need to say birth year is defined by this. Okay, this type checks, great. So that's the idea. We're just going to write it like this, try to have as close as possible a representation here that just matches very clearly the specification. See how we just say birth year, at least 1920 and at most 2002. And we've written birth year is an int between 1920 and 2002. We could be a bit more like fanciful if we wanted and include a thing here that says birth year, a useless part of the tuple, but I'm not going to. That would be good in a production program to document things better. So the issue year is a rule for int between 2010 and 2020. And the expiration year is a rule for ints between 2020 and 3030. 2030, not 3030. That's quite a long issuance date. Okay, now height and hair color are more exciting. Or just height, actually. Because it's kind of intish, but it has some junk in here, right? So what we want is height to be a rule of Once we've parsed the rule, we won't know what the units were anymore. So let's actually just define a little type here. Data height equals cm int or in int. And we'll make a rule for heights and then a function can I like turn on lambda case? I don't usually work with many extensions, but lambda case is going to be convenient here in a minute. Rule, actually, I don't even know if lambda case works for, yeah, it does, of course, that's the whole point. Idiot. Rule for, now we need, it's a slightly complicated one. Let's just define a parser for heights as well. Height is a regex from char to height. Height equals it is, I guess we should say it's either a cm over string cm and then an int. And so this parses, this is correct, but not what I want. It's not all of what I want. Or else it is an inches over string of int. Now, does this type check at all? It looks like it does. Well, actually, how would you even know when the whole file doesn't parse? Eh? Why? Ah, do I need parents here as well? Yes. Maybe I didn't need them in the other place. Yes, okay. I never quite know how the parentheses work on these things. So let's just check this real quick. What is the height? Well, actually, what I mean to say is 5 cm height. Oh, I don't have a show instance for it, but it did succeed. Nothing. Oh, you giant fool. They're in the other order. Int there, int goes there. And one nice thing about working with regexes instead of with parsers is that it's actually fine to have look ahead, because regexes can implement that efficiently, whereas parsers have to do it inefficiently. So we can afford to match an int and not know what to do with it for a while, and then eventually we find out, and that doesn't cost us anything. Yeah, that's 5 centimeters. That's 5 inches. 5 miles. No such thing. Great. And so now we have a rule of height, which is given a lambda case cm. We need a closed parent there. Actually, I think we don't even need the parents. Is that right? Is this parse? Yeah, it's just warning me, so this is fine. Between, how many centimeters are we allowed? 150 to 193. 150 to 193 cm. And for inches, we are allowed, I think, 59 and 76. What is this mad about? Oh, in is special. It's a special token. Okay, so this parses. Great. And we need hair color, eye color, and passport ID, which all don't need any validation. They just need to match a regex. So we'll just define another function here called regex, which is a function from regex to anything, I guess, that returns a rule. It needs no follow-up. Regex of RE equals... This is looking kind of stupid, isn't it? Or no. I have to... I guess I need to say is just of matching with RE. Yes, I would like to add the import. Is there some way that like you can add the imports? I don't know how to. There's some button. Fly check. I don't know. There's a million things you can do with fly check. Whatever. I'll just type it in by hand. So now we can just write HCL is a regex of now I want to combine a list of strings. This is hair color. Combine a list of strings with alternation. Is there such a function in Haskell? I have an alternative f. I have a list of fa, and I want out an fa. Choice. But choice is not defined. Ah, I want asum? That's infoldable. Okay. Regex of asum. Hang on, let me bring you back here. To map string of, and now I can just write all the cases down. If I can get those windows both in view at the same time, which is harder than it would sound. Map string of amb blue brown. Oh, I typed the E. Brown, gray, green, hazel, other. Oh, I need to import it from foldable? Okay. Import data foldable. Wait, where was it? Was it actually in foldable? I think so, right? Yeah. Data foldable asum. Actually, I want to write that, right? Asum of map string of this. There we go, that parses. I should be checking these, but I'm not. Oh my gosh, I moved my windows around to be able to see all that, and now I'm like, okay. Let's put this on new line so it fits on one line here. Oh, that's nice. Haskell mode knows where the comma is supposed to go. How did I never notice that before? What's left to match? I lost my advent of code window. Here it is. You guys can't see it, but that's all right. Eye color. We just did that. Oh. No, I see. I made a mistake. I wrote hair color, but I implemented eye color. So this is eye color. And we need one here for H color, hair color. Which is a regex of a hash followed by replicate M6 of a sum, yeah, that's fine, I guess. Map sim of there you go. It's a little like lame. Wait. This does not type check. Oh, it doesn't parse? Oh, I have this. There we go. Okay, so where's replicate M? I thought it was. It's in base somewhere. It's in control monad, even though it works on applicatives, which feels pretty stupid. But it's just like you know, legacy stuff. Import control monad replicate M. Cool. I just realized I have my window from yesterday's Advent of Code open that I could have reused, but instead I made a new browser window for reading today's Advent of Code, whatever. Okay, what's left to handle? Passport ID and country ID. Well, passport ID is easy. Because it's just... Oh, and we're ignoring the country ID, so there's just this left. So passport ID is... Oh, it does need to be digits. Okay. Regex of replicate M. We want exactly 9? Yes. Replicate M9 of psim is digit. And that's about it, I think? Yeah. So I like this rule definition where there's some place. I've talked before about how what I like to do in Advent of Code is model the domain well and try to implement reasonable, reusable primitives and combinators, even if like you don't necessarily need that much fanciness. Like we could just like map over all of our passport things and do a case match on each key and say, oh, if it's birth year, then check what it's between. If it's issue year, then check what it's between, and so on. But I like... That would be a bad way to write a production program, right? Your production program should somewhere list all of the rules that matter. And I like that we can... Everything that you know in the domain should be a value somewhere in your program, not just part of the control flow, would be the ideal. Sometimes you can go a little too far with that, but that's what I like to work on for Advent of Code generally. Sometimes I'll take shortcuts because it might take too long, but I think this was a productive exercise. I described the rules relatively well, and now it should be very simple to implement part 2 using them. Part 2 is, again, length. It feels like this season has so far a lot of text processing and a lot of like checking if things are valid. I wonder if text processing is the theme for this year. There's often like a theme that is revisited many times. Last year it was kind of this virtual machine thing. There was a previous year where there was a lot of like search problems, graph search kind of things, or traversal at least. We'll see. Anyway, it would be interesting if text processing were the idea here today. This year, rather. So we kind of want to filter valid has all fields. Is this? Oh, but I want, I don't want to move that in. I just want it to be this. And then, so what's the type of has all fields, please? Oh, whoops. Int. It's a map. Okay, right. Has all fields is a function from passport to bool, I suppose, right? Oh. Yep, there you go. That's better. Valid field values, which I will need to define, of course. Where valid field values equals all of check field on m dot elms. No, m dot. Oh, actually, it should just be foldable. No, if it were foldable, it would be only by the keys. So, how do you get, like, I forget what it's called. I just want to look at the whole conversion to a list. Oh, it's just to list, of course. Check field. So we've gotten a single map and turned it into its key value pairs of field, let's say name value. Let's just, does this type check at all? No. ToList is not automatically imported from foldable. Whatever, we'll use m.ToList. Oh, I want maps ToList anyway. Phew. Okay, so this type checks, which is kind of surprising but nice. Is equal to, we want to look it up in a rule, or in rules, right? From maybe false of I want to look a thing up in a map. Query, I have a lookup, sure. Oh, I could find with default and just return false if it's not there. That's kind of better instead of using from maybe. M.find with default takes the default value first. We want const false, and then it takes the key, right? Yeah. Name. And we just apply that to rules, and then apply the result, which is a function, to value. It type checks. Okay, well, let's try it, I guess. I mean, I don't know. It's not super likely to work. Oh, I didn't commit part 1, did I? I got a number though. That's exciting. And it's smaller than the first number, but not by a ton. Okay. Oh wait, I did commit part 1. That's right. Yeah. It was just there was a change I was thinking of doing in between part 1 and 2, and I decided to make it part of part 2. Okay, well, let's try that number, 172. There you go, the right answer. That's the magic of Haskell, right? If it type checks, it runs, sometimes. If it type checks, it's correct, sometimes. We definitely had some counterexamples recently, but this time it worked. Cool. So let's just we'll just add everything and commit it. Day 4, part 2, and look at how much like what did we end up doing? We imported a few new things. We defined actually quite a lot, which is fair. I don't think this is stuff I should have predicted. I could have parsed the inputs, but like, who would even know how to parse some of them? Centimeters and ints and years, you could maybe guess, but okay. What more to say about this? Oh, did I use this just? I did, right? Yeah. Yes, we built a tiny little language of combinators, which is nice for creating rules. And we did it in a way that we didn't really have to repeat ourselves much in all of this stuff, right? Birth year is a rule for ints, and they have to be between these things. And if we'd needed a rule that wasn't about being between two values, that wasn't baked into our idea of a rule for ints. We could have had a rule for int that says it must be 10, right? No problem. We have our rule for heights right there in the rule book. We have data for representing heights, and again, seeing the praises of applicative regex is that there's all this, you know, you don't need to bake a bunch of stuff into the regex library if the regex library is expressed in general enough terms that you can apply the type classes from the standard library to it, right? Because a regex is applicative, we get replicate m, and that's our repetition operator. We don't need, you know, curly brace 6 to be part of our string language. It's just part of the base language that applies usefully to regexes. Likewise, we have asum, a way to say, here's a list of things, match any one of them, rather than needing the concept of character classes to be part of the regex language, right? When you define regexes as a DSL, it's hard to call it a mini DSL. It is a gigantic DSL based on strings. It's sort of more portable between like source languages in that like PCRE kind of works reasonably okay in Perl, Python, Java, C, you know. But it's this very big thing that every language has to implement. And then at the end, you don't even get anything that nice. But here you can compose small regexes into large ones using the same building blocks you use for everything else, right? We used replicate m in day 1 for taking n items from a list. Well, it turns out for regexes, those have an applicative instance that does something meaningful for replicate m. And in general, replicate m is meaningful for every applicative instance, just like what it does will be different. And for regexes, it means match this thing n times. And asum, for an alternative, takes a list of things and gives you a choice of any one of them. So I don't know. I thought this was pretty cool. I'm especially happy with how the rules ended up looking. The rest of the program was like fine. And parsing the passport was, I guess we did that in part 1, right? But I think it was also okay. It's nice to have the string parsing be smart instead of being a single long string. But this is not really exceptional, I think. It's just fine, because it is a kind of messy regex. Whereas I think the ones that we wrote up here were very nice. Anyway, we can stop talking about that now. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.